12.3 is where we started Friday. Is that better? Okay. 12.3. Just a quick review. Okay. We started talking about permutations and combinations. Before we got to permutations, remember we started talking about fundamental counting principle. And that was just the idea that, for instance, to find how many pizzas you wanted at Manuel's Pizzeria, we could multiply the different choices, right? And then we spent a good deal of time talking about permutations. Okay, we're getting ready to talk about the opposite here in a moment, which is what I want to review. So remember, in permutations, order matters. Okay, that's going to be the key there. We talked about a formula for it, and I showed you different ways, right? I showed you the calculator trick at the very end. I saved that for the end. But we talked about how we could, permutations, we could write it out with blanks. Works for permutations, but not combinations. And we talked about the formula and how we could use that. Okay, but key there is that order matters. Now, today we're ready to talk about combinations. And when we talk about combinations, a combination is a set of objects with no specific order. Okay? A set of objects with no specific order. And so you'll often hear me say, order does not matter in this scenario. Okay? So with a combination, order does not matter. The number of combination of R objects taken from a set of N objects, and we have a formula, NCR. And it is N factorial divided by R factorial and N minus R factorial. Okay? And it's, R has to be between 0 and N. That's just saying that N is bigger. But we have a new formula. Now, this formula is very similar to our permutation formula, if you remember what we did on Friday. Okay? With permutations, we just didn't have the R factorial on the bottom. We had N over N minus R. Now we have an R factorial. Okay? So, N objects chosen R at a time. Order does not matter in this scenario. So let's look at some examples. I'm going to show you some different ways. I'm not just going for the calculator button, okay? The calculator button is there. It's good to use. It's good to know. But I'm not just going to rely on that. I want us to be able to do the setup, do some canceling, so I'm going to show both, okay? So, Marisol is planning to be a counselor at a summer camp. She can choose 3 activities for her sessions. The first question is, how many different combinations of 3 activities are possible? Now, we don't even have to think about whether or not order matters because it flat out uses the words, how many different combinations. Here's the thing. As you look at the summer camp activities, does it matter the order you pick them in? No. Now, if we were talking about the order that she completes the activities, that's a different step. That's a different story. But in just picking 3 activities for her to do, order's not going to matter. So that's why this is a combination. Now, how many different combinations of 3 activities are possible? How many is she picking from? If you count up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 activities if you haven't counted. And how many is she trying to pick?
3.
3. So officially, this is 10C3. It's the combination of 10 items picked 3 at a time. Now, as we set that up, look at our formula. Our formula says what? N factorial. What's N? 10. It's your bigger number, your number on the left. So 10 factorial divided by
R, so 3 factorial, 10 minus 3 factorial.
Okay. R factorial, which is a 3 factorial. And then N minus R, which is 10 minus 3 factorial. So similar to what we did with permutations, just slightly different, right? Now, if we clean this up just a smidge, 10 factorial on top, on bottom. 3 factorial is 3 factorial. What about 10 minus 3 factorial?
7 factorial.
7 factorial. Okay? Now, with that in mind, can we work this out? Okay. What does 10 factorial mean?
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, so I don't necessarily remember who was and wasn't here on Friday, but 10 factorial, that's not an exclamation point. That's a factorial in math class. And it means you multiply from that number all the way down to 1. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, in the denominator, 3 factorial means what?
3, 2, 1.
3 times 2 times 1. 7 factorial means what?
7, 6, 5, 4, 3, 2, 1.
Okay. 7, 6, 5, 4, 3, 2, 1.
Can we just cross out 7, 6, 5, 4, 3, 2, 1?
Okay. And yeah, let's talk about what can we cancel. Okay. In other words, you don't have the fancy button on your calculator, let's find out ways we can make life easier. So the idea, if you remember what I talked about, is basically a number on top can cancel with a number on bottom. Well, you've got 7 on top and bottom, 6, 5, 4. So basically, I'm just going to make that one fell swoop. 7 through 1 can all cancel, yes?
We have to keep the other 3, 2, 1?
Well, we don't have to keep them, but they don't get to cancel with that 3, 2, 1. Right, you don't get to cancel 1 3 on top with 2 3s on bottom. But what do we know about, for instance, the number 3 with a number on top? Does it divide into anything on top? Does 3 divide into 9? Now, this takes us into that whole cross-canceling thing that you guys aren't really big fans of canceling, I know, but I'm just trying to show you it works. Okay, so if you wanted to, you have 2 options here. Could you just multiply 10 times 9 times 8, 3 times 2 times 1, and divide those? Of course. Or we can look at, okay, a 3 on bottom. 3 divided by 3 is 1. What's 9 divided by 3? That's a 3 on top.
And then 8 and 2.
I would say, what about that 2? Michaela sees it with the 8. The other option is you could divide it with the 10. Does it matter? No, it doesn't matter. So 2 divided by 2 is 1. 8 divided by 2 leaves you with 4. So now, the only thing that is on bottom is a 1. 1 is 1. It doesn't matter. What remains?
10, 3, 4.
10 times 3 times 4. Well, I personally can do that one in my head. Because I know 3 times 4 is 12. 12 times 10?
120.
120. So there are 120 different combinations of picking 3 activities, since she has 10 to choose from. Doesn't seem like that many, but technically how many different combinations she could come up with. Okay, got it? Okay, let's go ahead and look at B. How many ways can a camper choose 5 activities from the 10 available activities at the summer camp?
10, C5.
You guys with her? You're choosing from 10. You're picking 5 at a time. It's still picking activities, so it's still order does not matter. Okay. Let's practice the setup. What's the setup there?
10 factorial. Wait, yeah.
Yep.
Factorial
Bigger number on top.
divided by 5 factorial. 10 minus 5 factorial.
Okay. So on top it's n factorial. On bottom it's r factorial. And 10 minus 5, or n minus r factorial. So, if I clean this up before I start writing it out, 10 factorial over 5 factorial times 5 factorial. Okay? 10 factorial means 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 5 factorial means 5 5 times 4 times 3 times 2 times 1. Another 5 factorial means?
You would cancel the second set.
Okay. Technically, it doesn't matter which set you cancel, but can you cancel one of those 5, 4, 3, 2, 1s? You can. Now, can we do some other canceling?
Yeah, 9 and 3. 8 and 2. Oh, actually, it could be 8 and 4. 10 and 3.
Okay. There's multiple different cancelings we could do here, right? How about this one? What is, and we could do this multiple different ways, but what is 5 times 2?
10.
So could we use 5 times 2 and cancel it with a 10? Are you guys with me there? 5 times 2 will cancel my 10. Now, could we have done 4 times 2 and canceled the 8 instead? There's options here, okay? Michaela mentioned the 3. 3 divided by 3 is 1. Which way were we canceling the 3?
6.
Okay, you could go with the 9 or the 6, right?
Yeah.
Doesn't matter. So if I cancel with the 6 becomes a 2. What about that 4?
9 divided by 8.
4 divided by 4 is 1. 8 divided by 4 is 2. Okay. Notice we got rid of everything on bottom again, didn't we? Okay. So the way I personally did this, I have what? 9 times 2 times 7 times 2 left. What are you guys getting?
So 252.
Okay. Have you guys played around with buttons on the calculator?
Yes.
Remember, on these calculators, any scientific calculator is going to have them in the PRV area. So right there, if I hit PRV, there's your options, right? NPR, NCR, and the factorial. So, for instance, we just did 10 PRV. You're over to NCR, 10C5, right? There's how you put in 10C5, and did we get 252? We did. Okay, if your calculator is different, by all means, it's there somewhere, and I can help you find it if you need it. Okay. Questions on those? And we'll talk tomorrow when I hand out a review worksheet for the upcoming quiz. But, because we're thinking, I think it's Quiz Thursday is my plan this week. But I'll talk about, what kind of work I expect to see and what types of problems on the quiz. Okay. So we'll talk about that a little bit more in the upcoming days. Okay, let's look at this next set. I just have it as additional combinations questions. We have what is 9C2? So that is the combination of 9 things picked 2 at a time. And you're like, man, we just did harder stuff. But you'll notice then the next one is what is the combination of 9C7? 9 things picked 7 at a time. And we're going to compare these two. That's the whole reason we're doing this. So, okay, what does 9C2 mean to you guys?
9 factorial over 9. Nope, 2 factorial, 9 minus 2.
Okay. N factorial over R factorial times N minus R factorial. So, if you want to clean that up, it's N factorial over 2 factorial times 7 factorial. Are you guys noticing a connection on the denominator? What do those two numbers on the denominator always add up to be?
Yeah, that's 9. 7.
Yeah, like 2 and 7 add to be 9. 5 and 5 add to be 10. 3 and 7 add to be 10. Yes? Are you noticing that connection? It's always going to be the truth. Okay, so here, 9, 8, 7, 6, 5, 4, 3, 2, 1. On bottom, 2 factorial. 2 times 1, 7 factorial. 7, 6, 5, 4, 3, 2, 1. What's happening?
Seven, 6, 5, 4, 3, 2, 1.
Okay, if we want to take the easy route, get rid of 7 through 1.
2 divided by, yeah.
2 divides into 8. 2 divided by 2 is 1. 8 divided by 2 leaves me with 4. I personally don't need a calculator at this point.
9 times 4.
9 times 4 is
36.
36. Okay.
I use my fingers.
Now, let's look at B. What changes up?
The 2 and 7.
Now we have 9C7. So when we set this up, 9C7. On top is still what? 9 factorial. What about on bottom? Officially,
7.
it's 7 factorial first, and then
9 minus 7.
9 minus 7 factorial next. So you end up with 9 factorial over 7 factorial times 2 factorial. Any thoughts about this before I put all my work on there?
The top and bottom.
Is it going to end up being the same thing?
Yeah.
9 factorials? It was 2 and 7, now it's 7 and 2. Does that order matter?
No.
No. It's going to end up being the same thing, and you're going to end up with 36 again. Now, you want me to put all the work out? Okay. Okay. This right here, this is the same. Okay. This is the same. There we go. I'll put an arrow. I'll take the idea. Okay. That works out to be identical. You just, it was just the order that it works out to be in there. Now, with that in mind, C is asking, what is the relationship between the answers to A and B, and why is this true?
Because they have the same answer. Because the order doesn't matter.
Okay, same answer. Order's not mattering here. Notice my denominators end up being the same, right? Okay, so kind of an interesting thought, right? When you're picking 9 objects, or when you're picking from 9 objects, whether you're picking 2 or whether you're picking 7, because 2 and 7 add up to be the same number, or to add up to be 9, it's going to work both ways. So, I'm going to say A and B are the same answer. And I think I'm just going to say because denominators end up the same. Okay. Okay. Feeling like pros at solving combinations now, right? Because now we've hit that point. We're going to put everything together. Okay? And we're going to talk about how do we know if something's a permutation, or how do we know if something's a combination. Okay? That is the direction we're heading next. So, as you notice, the title of my next section is Mixed Examples. Mixed examples because could be either or. Okay? So, as you start reading, you'll notice mixed examples. Do the possible outcomes represent permutations or combinations? So, on A and B here, I'm not actually asking you to find how many. I'm asking, what are they? Are they a permutation where, if you recall from Friday, order matters? Are they a combination, like what we've talked today, where order does not matter?
They're all different, like outcomes they could be, like 1 through.
Well, okay, so here on 1, 2, 3, we'll actually number-wise talk about it. But A and B, I just want to know.
A is a permutation.
Jennifer will invite 3 of her 10 friends to a concert. Is that a permutation where order matters, or is it a combination where order does not matter? Okay, I've already heard both answers. Great. Okay, now it's time to discuss.
I think it's a combination because it has like the whole of like her 10 friends, and then it says that she has to pick 3.
Does it matter whether you're the first friend, the second friend, or the third friend picked?
No.
No, it just matters that you're one of the 3, right? You don't want to be the 4th person picked, but that has nothing to do with, it just matters you're one of the 3. It doesn't matter which one of the 3. So this scenario is indeed a combination. Okay? This is a combination. Your explanation? Order does not matter. Okay, so if you want to put an explanation there. Order does not matter. Now, change up Jennifer's scenario. Jennifer must decide how she and her 3 friends will sit at the concert. Does order matter here?
Yes.
Okay. Now we're talking about, this might be a good way, how many arrangements are there for Jennifer and her 3 friends? Is it Jennifer, friend A, friend B, friend C? Is it friend A, Jennifer, friend B, friend C? I'm just, So this is a scenario where it's a permutation because order matters. Okay? So remember, if order matters, you're arranging objects. Okay? If you're trying to arrange something in so many slots, she's trying to take her 3 friends, arrange them in so many slots. A was a combination. She was trying to see how many we're asking how many combinations of 3 out of her 10 friends could be made. Okay? Now, on the second set here, this time we're actually going to find some numerical answers.
Permutation. First one.
But we have to decide, is it a permutation or a combination before we actually do the math? Okay? So, how many different ways can a 4-person team be chosen from a group of 8 people? How many different ways can a 4-person team be chosen from a group of 8 people? Does order matter, aka permutation or combination?
No, because it's 1 person.
It's a 4-person team. Do we talk about the order within that 4-person team?
You just talk about different ways.
Did you get picked for that 4-person team? So if we're talking about did you get picked for that 4-person team, this is a combination. Okay? Order does not matter here. Now, combination, we actually want to find this combination. Combination of how many things picked how many at a time?
So 8C4.
8C4. You're picking from 8 people, and you're picking 4 at a time. Okay? What do we know about 8C4? 8 factorial over, okay, this is a good test. You got to remember combination. Which one is
4
this?
Factorial, 8 minus 4 factorial.
Okay, so this is r factorial and n minus r factorial. So 8 factorial over 4 factorial times 4 factorial. Okay? Know that setup because you've got to know how to set up a permutation versus how to set up a combination. 8 factorial means 8, 7, 6, 5, 4, 3, 2, 1. 4 factorial means 4, 3, 2, 1. Another 4 factorial means 4, 3, 2, 1. Did you do some canceling? The easy way of most of you have figured out, get rid of the 4, 3, 2, 1. Did you guys do some canceling past that?
4 and 8. 3 and 4. 3 and 6.
4 and 8. 4 divided by 4 is 1. 8 divided by 4 becomes 2. You said 3 and 6. How about I go another step farther? 3 times 2 is 6. Could we just get rid of it that way?
Bottom's done. So 2 times 7 times 5.
2 times 7 times 5. 2 times 5 is 10. 10 times 7 is 70. So there are 70 different ways there. Okay. What about problem number 2? How many different ways can 12 runners in a race finish first, second, third?
Because it's how many in order for second and third.
Okay. Does order matter when we're talking about finishing first, second, third? Yeah, you want to finish first, right? You don't want second or third. Well, I think you want to finish first. But when we have placings, order matters. So because order matters, this is a permutation. Okay, order matters, it's a permutation. Permutation of what?
12.
12 runners arranged
Third.
3 at a time. Because it's how many different ways could 12 runners have a first, second, and third? Okay, now let's see what you guys remember. What goes on top?
12.
12 factorial. It's always n factorial on top. What goes on bottom?
12 minus 3 factorial.
And it is just the 12 minus 3 here. So 12 factorial over 9 factorial. Now, do you guys remember how this works from Friday? 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Could you shortcut this some? Yeah, because what's going to happen here? On bottom, yep, 9, 8, 7, 6, 5, 4, 3, 2, 1. By all means, feel free to shortcut that some, yes? What happens?
12 times 11 times 10.
Yeah, 12 times 11 times 10. 9 on down cancels. There's nothing else extra to cancel. We end up with
1 on bottom.
1 on bottom. What's 12 times 11 times 10? 1,320. Okay. Okay. One last one on this section. How many ways can 11 contestants for an award be narrowed down to 3 finalists? Eleven contestants be narrowed down to 3 finalists.
Combination.
Why?
Because it doesn't matter what 3 are, it's just down to 3.
Okay, we're not talking about a first, second, third here, are we? We're talking about, did you make the cut? Are you in those 3 finalists? So this is indeed a combination. Now, I'm going to save us some time. It's going to be a combination of what?
11.
Grab your calculator. Tell me what 11C3 is.
165.
165. If done correctly, would the math by hand work out to be the same?
Yeah.
Yes. I'm ready to move on to the back. That's really what it comes down to. Fair enough?
I use the bathroom, please. Because then I want to come back. They go nothing.
Okay. On the back side, we're going to talk about probability. Okay? So we're looking at probability where the combinations or permutations are going to be involved to find the probability. Okay? Now, with that in mind, okay, let's look at this scenario here. Okay, we're talking about finding probability. We're still going to have to talk about does order matter, but then we're finding probability. So total number of favorable outcomes over total number of possible outcomes is what we're looking at here. So a teacher chooses 5 students at random from the names shown together to work on a group project. What is the probability that the 5 students' names begin with a consonant? Okay. So, should we figure out some information about all these names? Like, how many names are there? I agree. Okay, so right now I'm just gathering info. There are 18 names, right? Question A asks about names that begin with a consonant. Do we need to review what a consonant is?
A letter that is not a vowel. So basically anything except for A, E, I, Y. Like sometimes it's Y.
Nope, forget Y.
I know. I learned in elementary.
I know, but we're
Y
just talking about the 5. We're just talking about the 5. So A, E, I, O, U. Okay. So probability that they begin with a consonant. So basically, when we talk about how many begin with a consonant, basically beginning with anything other than a vowel. How many begin with a consonant? Basically, skip all the vowel ones. What? 1, 2, 3. There's a vowel. 4, 5, 6, 7, 8, 9. There's a vowel. 10, 11, 12, 13. Did I do that right? Okay, so there are 13 names that begin with a consonant. So, with that in mind, okay, teacher chooses 5 names at random to work on a group project. Let's talk. Does order matter?
9.
No. Okay, or correct. Order does not matter. So when we work on this problem, we're going to talk about this problem in terms of combinations. Now, okay guys, probability. Total number of favorable outcomes on top. All possible outcomes on bottom. Okay? We're looking at the probability that 5 names are chosen. Okay? So 18.5, that is your denominator. 18C5 is your denominator. Because you're choosing from all 18 names. How many combinations are there when you pick 5 at a time? Okay? Now, what's going to go in the numerator? 13C5? Because we're picking how many names? Are we picking from? And that's 13. 13C5. Now, I'm all in favor of you guys knowing how to do the setup and all that, but do we really need to do setup over setup? We practice a bunch on the other page, yes? Grab the calculator. Grab the calculator. Okay? Make sure we know how to do this on the calculator. Tell me a number for 13C5, a number for 18C5, and then we can divide them.
1,287.
Okay. 1,287 on top. Denominator? 8 what? 8,568. Okay. Now, my answer key has this going to a percent.
Yeah, 0.1502. So
0.1502. I have 021, but anyway, about it. Doesn't matter. What is this as a percent? Approximately 15%. Okay. Okay. Got it? Okay, change the question up. What is the probability that 5 students' names end with a vowel? Oh, what's that mean we got to do this time?
count the vowels.
Yeah, let's figure out how many end with a vowel. So end with A, E, I, O, U.
7, 8,
12.
I have 12. End with a vowel. Just gathering my data here, writing the information down. Okay, so probability that 5 students' names end with a vowel. How many total possibilities would we be going out of? It would still be what?
18.
18C5?
And then top to the 18.
12. It'd be 12. C5.
Oh, yeah, 12.
You're picking from the 12 that end with a vowel. And we're trying to get 12 or 5 at a time. So 12C5. I'll take the denominator this time. 8,568.
729. Wait, no. 92.
Okay. 792. No one's arguing with her, so did she get herself corrected?
I think I just turned this left.
I think so. If we turn this, go towards a percent.
0.09243.
Good enough. Which is approximately what is a percent?
92. 9.
Move over 2 decimal places, 9%. Or 9.2% if you want. Okay, I'm realizing we're not going to get through this whole page, but you're starting to see probability, right? Let's go ahead and talk about this next one. This will be a good one to possibly have to just end on, but that's all right. A company wants to form a committee of 4 people from its 12 employees. How can you use combinations to find the probability that the 4 people newest to the company will be selected? Well, they gave us a hint here, yes? How can you use combinations? So,
C4.
what'd you say?
12C4.
Okay, so 12C4 is going to be my denominator because we have 12 people, 12 employees, and we're trying to form a committee of 4. So you're picking 4 at a time. And you're just picking a committee, so order doesn't matter, that's combinations. Now, what about on top? We want to find the 4 people newest to the company. The 4 people newest to the company means that is how many people?
4.
4. And how many of them are you trying to pick?
4.
4. So it's what? 4C4. Now, if order doesn't matter, and you've got 4 people, and you're trying to pick them 4 at a time, what is 4C4? 1. Over
495.
12C4 is 495. Now, this one, in my answer key, don't ask, it is just as a fraction like that. Could we go to a percent?
Yeah.
Yes, we could, but my answer key didn't. Okay? Okay. We're obviously not going to have time to do the next section, but trying to think. Students will be chosen at random for school spirit awards. There are 6 athletes, 8 non-athletes who are eligible for 2 possible prizes. What is each probability? Okay. They're chosen at random for school spirit awards, and there's 2 possible prizes. Does order matter?
No.
No, it doesn't matter whether you're the first or the second one picked, right?
Yeah.
And so, again, this would be another combination. You will find that more often than not, the probability questions turn out to be combinations. Okay? So, we didn't get through this last page, or last half the page, but you've seen some probability, yes? Okay. So, I can definitely, by all means, come up, cover any questions tomorrow. Plan on 12.3 Savas, working on getting it done for tomorrow. If you have questions, bring them to class. And then I will have a review worksheet to hand out for quiz review starting tomorrow, quiz on Thursday. Okay?